Hello SGD, Sacred Geometry Decoded. This will be part 14 in this series, and just a few added points. So already previously we've gone into Vitruvian man. Man is a measure of all things, how the English imperial system by the proportion of the Vitruvian man also corresponds to the number of actual English feet to make the ideal Egyptian of 4 Egyptian Royal Cubits high. The relationship between the foot, the metre and the cubit. For instance, it's a still image, but if you were to make a 1 metre long pendulum, you would swing it no more than 30 degrees, and this is a bona fide thing. If you swing it more than that, it affects the timing. Just like a grandfather clock, a pendulum needs to be swung at a shallow angle, and a 30-degree angle would just happens to create pi over 6 metres, and that is 1 Egyptian Royal Cubit, 86,400 seconds per day, which is multiply the maximum visible base of a pyramid, including the sockets, you get the circumference, equatorial circumference of the Earth. Multiply the height of a pyramid, including the paving stones of a socle, you get the polar diameter of the Earth, describing the oblate spheroid of the Earth, unrivaled until modern times. So 1 metre, 1 cubit, 1 second connects the foot, the metre, and the cubit. Also, we'll get into that more in the future, but Alan Green, I linked in the last video, he was the one to put together the metre and the cubit to get this 5:6 ratio, or which brings us back to the Salamis stone. That's just an etching of it, but the Vesica 3:2 ratio, that's Khafre's pyramid. Square root of 5 Egyptian Royal Cubits to within 1/3 of a millimetre. Now, the relationship, the margin of error between the metre plus Egyptian Royal Cubit plus foot being 0.396 millimetres, there's 0.33. Some really interesting information in regards to there, but square root of 5 Egyptian Royal Cubits, square root of 5 as it relates to the golden number, or Phi, or the divine proportion. The Salamis stone being a conversion tool between multiple sets of units is being an important feature, just like the symmetry of a temple as described in Vitruvius must have, man is a measure of all things, and the symmetry between the parts of a human body should be represented in the temple design, as we can, the pyramids for instance, as we saw earlier, the golden ratio. So Phi equals the square root of 5 plus 1/2. Well, the square root of 5 plus 2 equals Phi cubed. Yeah, it's just a beautiful number. It's unique amongst all the numbers, really, and it's so important in nature, so many different aspects of it. But which will bring us to the red pyramid, the capstone found next to it, or the pyramidion. Originally 1 metre high and 3 Egyptian Royal Cubits, or pi over 2 metres wide at the base. It's since been, I just call it vandalized to change, but this is just like the Salamis stone, a conversion tool, not just between the units as in the metre, the Egyptian Royal Cubit. This particular capstone is also a scale replica of the Great Pyramid, which gives you Phi, Pi, and all these other proportions. But so the Egyptian Royal Cubit and the metre, now that would correspond again with a 1 metre pendulum, creating a very, very accurate 1 second clock, and that corresponding to 1 Egyptian Royal Cubit and the rates of seconds per day. We'll get into more in this, but so the capstone here has the same 7 high to 11 wide proportions of a Great Pyramid, which gives us the golden number, or very good approximate of it. And again, when you look into the actual measures and the pyramid, the imperfection will lead to a series of perfections. So these good approximates of 7 to 11 ratio essentially becomes accurate as what is possible when you look into it deeper. But the metre, the Egyptian Royal Cubit, the foot linked by time, linked by proportion, linked by the ideal English measures of 4 cubits or 6 feet by the English scale. The margin of error, width of a hair between those three, would give you precisely 6 feet, 6/5 ratio. So 1 metre plus 1 Egyptian Royal Cubit is 5 feet. A metre plus an Egyptian Royal Cubit plus a foot is 6/5. Now, so let's look. So 1 metre wide diameter, that circle using the seed of life, the hexagonal geometry, which is again a constant. If you draw circles, all keeping the same radius diameter, you create the seed of life, the flower of life, fruit of life geometry, which is full of information. And that so 1 meter diameter, therefore pi meters circumference, 1/6 of that being 1 Egyptian Royal Cubit, 5/6 times pi, being within, again, the thinnest human hair distance from exactly phi plus 1 or phi squared meters. So that's shown as a circle. So if we just have it here in linear form, so 6 Egyptian Royal Cubits is, again, splitting a split hair, pi meters. 5 Egyptian Royal Cubits is the thinnest human hair margin of error from phi plus 1 or phi squared meters. So again, these margins of error, these ever so slight ones, but also when they're 1/3 of a millimeter, the margins of error will point to information, and especially to time and the relationship. But now, for instance, the Great Pyramid, using the idealized measures for the moment, 440 Egyptian Royal Cubits at the base. Therefore, the maximum visible is 880, 280 Egyptian Royal Cubits high, so 880 divided by 280, you can reduce that to 22/7, which is one of the best way as a fraction to describe pi. If you're to do that in real-world engineering, apart from extraordinary precision components, this would be well above achievable margins. And back to that 6/5 ratio, so including the subterranean portion. So above ground, it's 5. Including the subterranean, the height is 6. And so again, 880 Egyptian Royal Cubits wide. So therefore now the ratio, including the subterranean, at this 5:6, you get ever so close to the golden number +1. So phi plus 1 equals phi squared. That's why it's so important. And it's 2.618033. Okay, 2.61904. So 0.001 is the difference there. But there's more to it in relation to meters and cubits, and especially the Great Pyramid. So again, I'm using ideal measures. I'll get more into the precise survey, because that just leads to another level of beauty. But so the height, 280 Egyptian Royal Cubits. That would, of course, missing the top now. And each base is 440 Egyptian Royal Cubits. So the relationship between cubits and meters there. So 440 at the base, 280 high. So this right angle triangle, which would be leads to a nice phi and pi ratio, but 280 Egyptian Royal Cubits high, 220 half base, 220 Egyptian Royal Cubits half base. So 280 plus 220 is 500 Egyptian Royal Cubits. 5 Egyptian Royal Cubits, so it's just that same number times 100. And this times 10 times 100 times 1,000 is a common feature in regard, well, how it links to Heliopolis, the links between the Great Pyramid towards Port Said and to Alexandria based on the angle of the pyramid, which maps out the delta. It's a repeated thing now. Lots of videos before on that, but just for the moment. So now if we add those together, we get 500 Egyptian Royal Cubits. If we subtract them, we get 280 minus 220 equals 60 Egyptian Royal Cubits, which is pi times 10 meters. So 6 Egyptian Royal Cubits, by definition, is, again, within all but the highest level of measurement would be pi meters. And so it's 60 Egyptian Royal Cubits, 280 minus 220 equals pi times 10. Now, if you go into the upper chamber, or the king's chamber, the long side is 20 Egyptian Royal Cubits, the short side is 10 Egyptian Royal Cubits. Therefore, you have a perimeter of 60 Egyptian Royal Cubits, which is the same number, 280 minus 220. So again, pi times 10 meters. Now, if you look at the maximum visible base, so 880, the base length times 2 is the most you'll see. And so 880 minus 280 equals 600 Egyptian Royal Cubits, which is pi times 100 meters. Now, this on its own, just this particular, if you're just seeing this video in isolation, well, it's so what, but in what's been shown previously, and as we extend it forward, this is a symphony of coincidence, how these things work together. So 1 or 2 points, well, okay, you could dismiss it, but the beauty of the inherent mathematical constants, the systems of measurement, how they come together to incorporate time, and especially when we get more and deeper into the pendulums, and it links not only Egypt but also to Mohenjo-Daro, and a few other interesting places. Okay, so I'm going to pause for the moment. Okay, so while we're on this, now for instance, the perimeter of a king's chamber, 60 Egyptian Royal Cubits, pi times 10 meters. Now it's right. Okay, and if we get the right angle triangle from the pyramid, 280 minus 220, 60 Egyptian Royal Cubits, again, pi over 10. And I'm going to cover this more, but just as a preview, for instance, this is the Loanhead of Daviot, one of these recumbent stones, unique sort of to Scotland, where you have this altar. John Hill did some fantastic work about the standard units of measure that define these places. So, for instance, the altar is an average of, a standard of 20 and a half modern English feet, which converts to a beautiful set of numbers. But what's important is that the diameter is 54 feet, and so that's times 2 is 108, and you see this as a standard across the ancient and the modern world. Also 54 feet, for instance, in the Manitoba Legislative Building, 54 feet, the Shriner Building in New York, 54 feet, statues here, statues there, but also across time. These are just some of the examples. So Mohenjo-Daro, the stone circle, also in Japan, which is at 108 along its longest axis, 72 on its shortest, which is 108 over 72 is a 3/2 ratio. But why that irrelevant? Because, so, for instance, these at 108 feet diameter at the triplet stones, for instance, therefore the radius is 54 feet, which all times in nicely, but 54 feet equals 31.434756 ... Egyptian Royal Cubits. 53.96765 feet equals exactly pi Egyptian Royal Cubits, or pi times, actually I should have said pi times 10 Egyptian Royal Cubits. I just threw that together at them. So we'll get more into this. I'm just focusing on the pyramids, but these ancient units of measure across ancient time, leading to some lovely information. And again, so the maximum visible base length, 880 Egyptian Royal Cubits, minus a height gives you 600, which is pi times 100 meters by definition, which brings us back to the concept of the 1 meter pendulum swung at 30 degrees, creating 1 second, also defining one Egyptian Old Kingdom Egyptian Royal Cubit at pi over 6 meters. And well, the pendulum, that's where the pendulum would be hanging, which would divide the Egyptian Royal Cubit into 2, and one Egyptian Royal Cubit divided by 2 is 0.261799, which brings us back to 5 Egyptian Royal Cubits, essentially being phi plus 1 or phi squared meters within 0.00404. So some examples of the measure of a unique geometry being applied in proportion, but also being measurable in these important features. So yeah, still laying down the groundwork to some of the heavier stuff, but I could just say, well, this is what it is, but it's necessary to see this and to check the calculations and have a look, and really still on the surface of this, but these constants, geometric, mathematical, essentially removes all chance of coincidence. There is a message here, I do believe. Have a good one.